Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 17, 2025, which was about a week ago. This paper proposes a single system that both animates a static character and replaces a person in video while preserving identity, motion, expression, lighting, and color tone. The paper is titled Wan-Animate, Unified Character Animation and Replacement with Holistic Replication, and as we'll see later, the results are really impressive. In tests, it reaches SSIM 0.813, LPIPS 0.227, FVD 118.65, with portraits at SSIM 0.834, LPIPS 0.205, and FVD 94.65. Alright. The previous segment outlined the goals and headline results. Figure 1 illustrates the two core modes. The left column presents the source character image, while the top row shows reference video frames that provide motion and expressions. The middle row displays animation outputs that mirror those poses and facial changes, preserving identity. The bottom row presents replacement, where the character is swapped into the scene so lighting and color tone match the environment for seamless integration. So while Figure 1 contrasted the two modes, Figure 2 shows how the unified pipeline ties them together. The vision inputs feed a VAE encoder that produces reference, temporal, environment, and target latents, with a mask deciding what to preserve. Control signals inject skeleton motion and implicit face features through body and face adapters. The latents then enter transformer blocks, where dedicated face blocks and the Relighting LoRA enable expression fidelity and scene lighting. A VAE decoder finally renders the video, so either animation or replacement emerges from the same design. Alright, the previous figure tied the pipeline together. Table 1 reports quantitative comparisons across methods. The left block covers general animation, where Wan-Animate leads with SSIM 0.813, LPIPS 0.227, and FVD 118.65. The right block focuses on portrait videos with SSIM 0.834, LPIPS 0.205, and FVD 94.65, which signals better identity and smoother motion because FVD measures temporal realism. Higher SSIM is better, while the other two should be lower. So while Table 1 quantified the gains, Figure 6 presents a side-by-side grid comparison for animation mode. The rows list Animate Anyone, VACE, Runway Act 2, Dream Actor M1, and the proposed system with columns showing matched frames. Competing methods show issues like blurry local details, pose drift, and inconsistent faces across time, which hurt realism. The bottom row highlights Wan-Animate with consistent identity, sharper textures, and motions that track the driver precisely, so the sequence feels stable and lifelike. Alright, the previous figure highlighted animation quality. Figure 7 shows a qualitative comparison for replacement mode, with rows for Animate Anyone 2, VACE, and Wan-Animate, and columns showing matched frames. The competing systems exhibit identity drift and softer details, which weaken realism during longer sequences. Wan-Animate maintains consistent identity and sharper textures, and the relighting closely matches the scene so skin tone and suit shading stay coherent across frames. Wrapping up, two takeaways stand out. A single DI-T-based pipeline controls body motion, facial expressions, and scene lighting together, and the results beat strong baselines in both animation and replacement. The broader implication is practical. Open tooling for film, games, and creators who need consistent, scene-aware character video. I am Alex. Thanks for listening.